this episode, episode 7, we're going to talk about cat filters and what's the difference with cat filters. Is there a difference? And we'll go through that. And I want to start this out by just saying this is not a sales pitch about why you should buy cat filters. This is telling you the technical differences about cat filters and why we think that they're superior. So again, we're not going to be bashing a bunch of different brands of filters out here. We're going to be talking about all the great advantages of cat filters. So with all that being said, let's go ahead and start the presentation. Before we get into the deep, dirty details about filters, let's talk about the agenda that we're going to go through today. So we're going to talk about how filters work, filter ratings. We'll talk about cat filter classifications. We'll talk about the difference in how Caterpillar builds their filters, and they take some additional steps that not a lot of manufacturers do. And then we'll talk a little bit about fuel filters, lube filters, and hydraulic and transmission filters together, just what the advantages and disadvantages of some other brands are. Again, we're not going to be harping on other brands too much, but we will mention some of those when we talk about fuel filters. So that's kind of the agenda for this thing. So the first thing is, how do filters work? Now, I know there might be some preconceived ideas about how filters work, and you're probably pretty close right off the bat with how filters work, right? We think of the media that's within the filter as a screen, right? So the job of the media is to capture the particles and allow the fluid to flow through. For fluid to pass through, the media has got to have holes or channels to direct the fluid to flow through the filter and allow it to pass through the filter, right? That's why the filter media is made of a porous mat, and it alters the flow, the fluid flow stream, and causing the fluid to twist and turn and accelerate during passage of the filter. So if you can imagine fluid flowing through, if we're looking at the upper right picture, which is a fluid filter that's been scanned with an electron microscope, and we can see that there's these strands going all different directions, and so that's causing the fluid to change direction as it flows through the filter. Like I said, traditionally we think of filters as a screen. Unfortunately, that's not the whole story with filters. If we thought of filters only as a screen, then the smallest particle that they would be able to capture would be determined by the size of the openings within the filter, right? So if we had, again, referring back to the picture on the top right-hand corner, if the size of that hole right there is the smallest hole in the entire filter, then that would be the smallest particle that we could capture. But that's not the way filters work. So let's look at the different ways that the filters work. So there's really, there's a few different ones, but there's 4 main ways that filters work. And on the left-hand side, we have sieving. So this is the most common mechanism in liquid filtration, and as well as air filtration. And that's when the particle, the black object you see there on the left, is too large to fit between the filter fiber. And so that as the fluid flows through that fiber, it captures those large particles. But that's not the only way we filter. That's the way we get the big stuff out of the fluid. In the top right-hand corner, we have something called inertial impaction. And this works on large, heavy particles that are suspended in the flow stream. These particles are heavier than the fluid that surrounds them, and as the fluid changes direction to enter into the fiber space, the particle continues in a straight line and it collides with the media. So you can see there how that fluid flow in blue kind of shapes itself around the media fiber. That particle keeps going straight because it's traditionally going to be a large, heavy particle. And then on the middle, on the right-hand side, we have diffusion. And diffusion works on the smallest particles, and the small particles are not held in place by the viscous fluid, and they diffuse within the flow stream. So if we think of the larger particles, the one just above that, they're kind of held in suspension with that fluid. They're kind of flowing along with the fluid. The smaller particles that we capture during diffusion are particles that are kind of doing their own thing. They're going with the flow, but they're not suspended in the oil. As the particles go through the flow stream, they collide with fiber and they're collected. And then the final one on the bottom right-hand side is something called interception. And interception works on particles in the mid-range size that are not quite large enough to have inertia, or they're maybe not heavy enough to have inertia, but they're not small enough to diffuse with the flow stream. So these particles are kind of that mid-sized particle or lightweight particles that we try to filter. And these mid-sized particles follow the flow stream as it bends through the fiber spaces, and the particles are intercepted when they touch the fiber. So that's kind of the four basic ways that filters work. Now, I've mentioned a whole lot about fluid filters, and this presentation is mostly directed towards fluid filters. But these same four principles are how air filters work. So these same things happen regardless of what the filter is filtering. So let's talk about filter ratings for a minute. Filter ratings, kind of a touchy subject when you talk with some, but they can really be broken down. There's a lot of different filter ratings out there, but we're going to talk about four main filter ratings. We're going to talk about microns, nominal filter ratings versus absolute filter ratings. We'll talk about beta ratios and efficiency ratings. And at the end of the day, the only thing that matters is that bottom one, efficiency rating. Beta ratios is how you get efficiency rating, and microns is important, we know that. But at the end of the day, efficiency rating is what matters. So let's talk about what is a micron. So it's a unit of length equal to 1/1,000,000th of a meter. If you already know this, sorry about that, we got to cover it. 1 inch is equal to about 25,400 microns. If you think about table salt, you know, one little piece of table salt, that's about 100 microns in size. Human hair is about 80 microns in size. Even going down to something like a red blood cell, that's about 8 microns in size. And so when we're filtering, we're looking at that less than 20 micron size generally is where our filters are lining up. So really, really small things that we're trying to filter out of the fluids and the air that our engines breathe and they live by, the machines. So let's talk more about nominal versus absolute. So there's two different really classifications, and it's important whether you're using Caterpillar filters or other brands of filters to understand how they rate their filters. Because the Caterpillar filters are built with a certain specification, and they don't necessarily go out there. Caterpillar doesn't provide a lot of micron ratings, and here's the reason why. Nominal rating for microns on a filter, that's the smallest object that a filter can potentially catch. So let's say we have a 5 micron filter, but it's nominally rated at 5 microns. That's the smallest object that the filter can potentially catch. So basically, a nominally rated 5 micron filter can potentially catch something down to 5 microns in size. For an absolute rating, it's the size of the largest particle that will pass through the filter. So if we have a 5 micron absolute rated filter, then anything larger than 5 microns will not pass through the filter. So there's a big difference right there. Down at the bottom, you see it says tests have shown that a 200 micron particle passing through a 10 micron nominally rated filter. So there are times when nominally rated filters will allow much larger particles to pass through. And I'm sorry I didn't mention this earlier. That funny looking U that you see there, that's the symbol for Micron. So the next on the things of topics to discuss on filter ratings is something we call beta ratio. Now, for most of us, beta ratio may be a new term, but it's something that if you get just a high level overview of it, you're good to go. So beta ratio is often used when expressing filter efficiency for a given particle size. In simple terms, it's the number of particles in the upstream before filtration divided by the number of particles downstream after filtration. The beta rating comes from a multi-pass method for evaluating performance of filter elements. So in the example that we have on the screen, we have 1,000,000 particles greater than 5 microns on the upstream side, on the red side, and on the downstream side, on the yellow or orange side, we have 1,000 particles greater than 5 microns. So the beta ratio with this particular filter, if we have a 5 micron filter element and 1,000,000 particles on the upstream side, and it allows 1,000 particles through the media, then a beta ratio will be calculated as 1,000,000 divided by 1,000, which will be a beta ratio of 1,000. And then we'll do some additional calculations to figure out efficiency, but we're not worried about that right now. So beta ratio is how many particles we introduce it compared to how many particles are downstream. So efficiency is what really matters when it comes down to it. On the left-hand side of the screen, we have a competitive filter that's a 5 micron nominally rated filter. On the right-hand side of the screen, you have a cat filter that's 5 micron absolute rated. In this case, we're just using 1,000 particles, which is a very low particle count, but 1,000 particles greater than 5 microns. We're introducing that to both of these filters. And out of the nominally rated competitive filter, there's about 500 particles greater than 5 microns coming out of the filter. On the filter on the right, the cat filter, 1,000 particles in, greater than 5 microns, and we get 13 particles out greater than 5 microns on the downstream side. So this is where efficiency matters more than micron rating. You'll hear a lot of manufacturers talk about their micron ratings, but efficiency is what matters. So if we take the beta ratio, and we're not going to go through these calculations in great detail, but if we take 1,000 from the particles that we have in the upstream fluid, on the left-hand side we had 500 particles coming out of that filter. We have a beta ratio of 2. And so the calculation that you see down at the bottom of the screen on the left-hand side is 1 minus 1 divided by 2, which will be 0.5. So 1 minus 0.5 will be efficiency rating of 50%. If we do the same thing to the filter on the right, we had 1,000 particles in, 13 particles out. That would give us a beta ratio around 75. And so the efficiency calculation would be 1 minus 1 divided by 75 would be an efficiency rating of 98.7. So there's a big difference in efficiency rating. These filter ratings are not all the filter ratings that are available to filter manufacturers. I want to be clear on that. They use a lot of different tests and a lot of different ratings to develop filters. There's many more that we don't have time to discuss today, like the ISO 16889 multi-pass test, or beta ratio curves, or beta stability, and we just don't have time to discuss them. But because the term absolute and nominal don't have published standards, we got to depend on the filter manufacturer to be forthright with their filter performance. You can always depend on Carter Machinery and Caterpillar to give you the correct filter for your Cat machine. And that's the message that I would like to send to you, is we can't always depend on these filter manufacturers. We have to know what you put on your machine. So let's talk about the Cat difference. The Cat filter classifications. There's lots of different types of filters. There's standard efficiency, there's high efficiency, or advanced high efficiency, and ultra high efficiency. And these filters have multiple different types of filters. Of course, we have hydraulic filters and fuel filters and water separators and air filters. But we have three basic classifications: standard efficiency, advanced high efficiency, and ultra high efficiency. Now, when you're talking about things like just a normal run-of-the-mill, say an oil change on your engine, a standard efficiency filter would probably be just fine. Now, if you're running in an area that's real dusty or dirty, you may, and you find maybe during your oil sampling process your silicon rate has gone up some, then you may want to switch to, say, an advanced high efficiency filter. The ultra high efficiency filters are mainly used for when there's been a problem with the system. Now, take fuel filters out of that scenario, but if you've had a hydraulic system failure or you're trying to clean your compartment out, then ultra high efficiency filter is your way to go. But you don't want to use that every single oil change or every single service. The challenge with an ultra high efficiency filter, while it does filter down and it does clean up that system, the service interval for that filter may be shorter, depending on how dirty your system was. So, you know, you have to be aware of that, and talk with your salesman, talk with the parts counter folks if you're having questions about when to use an ultra high efficiency filter, and you know, maybe they can point you in the right direction on that. So what makes Cat filters different? Cat filters are built by a company called AFSI. Now, AFSI is owned by Caterpillar, and it's Advanced Filtration Systems Incorporated. They have two locations, Champaign, Illinois, and in the Czech Republic. They are automated manufacturing. Very few person interactions with the filter. It's done a lot by the computer, by different types of manufacturing processes that are automated. Reliable product quality because of that. That's what you get out of it. Now, what's the difference? The difference is, let's start with the can. Caterpillar cans, the canister itself, is the thickest in the industry. It's a one-piece design, so if you look at where the end plate goes onto the can is molded around the end plate. It's not pressed into place. So the can is the thickest in the industry. It's heavy duty. It's also powder coated for additional corrosion protection. The aluminum top plate, so the plate that you see when you pick up the filter, it's made out of aluminum, which is a non-ferrous metal. Now, if there was an error made during the manufacturing process, would you like to have loose shavings from stamped steel or loose shavings from aluminum? Now, Caterpillar goes through the process to make sure there's no shavings, but it's an aluminum top plate. It's not going to have any kind of steel or any kind of other metal enter your engine if there is a problem. Reduces harmful contaminants maybe from manufacturing, and of course there's more thread engagement. So if you look at the Caterpillar filter, there'll be much more thread down in the filter to screw up onto your filter base than other brands of filters. Now that might not mean a whole lot to us as long as the filter goes up on there and stays tight, but how long are you going to run that engine versus how long you're going to run the filter? If we have to sacrifice the threads on anything, we want to sacrifice the threads on the filter and not the threads on the machine. So as I said, most top plates are made out of stamped steel and they've got just a few threads. Again, stamped steel top plates can also risk contaminating the fluid through the manufacturing process. Now, before they build the filter, they have a machine that creates these pleats. And when the pleats are coming out of the machine, they run an acrylic bead over top of the pleats that holds them together and spaces them out perfectly. The acrylic beading prevents bunching in the filter, and it maximizes the media usage. So if you have a group of pleats that are all bunched together, then those pleats that are bunched together, they can't be filtering because it's preventing fluid from getting in between those pleats. So it maximizes the surface area utilization. And the last thing it does is it stabilizes the pleats. It prevents the pleats from moving around. They have urethane end caps, so it's a one-piece design. They take the filter media and they pour it into a mold, and they put it in a mold and they inject this liquid urethane into that mold. So you can see that we've got this molded end cap, and the end cap where the urethane goes down in between the filter media. And that prevents any leaks from going around the end of the filter. Most filters, if you cut them open and look at them, they have a stamped steel end cap and there's no seal there. So fluid can be allowed to go through the ends of the filter rather than through the filter. Spiral roving. So this takes place after the filter is created, after the end caps are in place. They spin this before they put the filter into the can, and this reduces pleat flex and fatigue. So if you've ever touched a hydraulic hose, I'm not telling you to go out there and do it, but if you've ever touched a hydraulic hose on a machine while the engine is running, you can feel the vibrations in the hose. Well, the filter's no different. The pleats can vibrate. And when they vibrate, they can allow contaminants to pass through the filter. So spiral roving can maximize the media surface utilization, increase contaminant retention. Remember, if we don't shake that filter, then it'll hold a whole lot more than what it would if we were shaking it. So this stabilizes those pleats even more. And the last thing about the build of the filters is they have a non-metallic center tube. Traditional filters use an extruded steel center tube, and they're usually thin steel tubes with stamped holes. And that thin steel tube is weaker than the non-metallic center tube. So if you have a lot of pressure within that filter, those center tubes can collapse. So the non-metallic center tube is stronger than the steel, and it can maximize the cleanliness by not introducing contaminants through the manufacturing process. So it's very important that we keep these filters clean from the day they start building it to the day you put it on your machine. All right, let's go through a few things about cat filters that show the advantage over the competition. The first one is fuel filters. So in this case, they took a C9 engine and they put it just the cylinder head on a test bench, and they ran fuel through these fuel injectors using 5 different cat filters. And so they ran it for a select number of hours. So they used the cat filter, they used the Wix filter, they used Baldwin, Fleetguard, and Donaldson filters. They ran them all for the exact same amount of time. They ran them all with the exact type of fuel. And what they found afterwards was the cat filter had very little damage in the injector valve seat. And you can see that area of that fuel injector over on the left-hand side that we're talking about. Compare that to the Donaldson, the Wix, Baldwin, and the Fleetguard that did have small nicks in that injector valve seat area. There's more on this. If you talk with your salesman about that, Cat published a big document about this. You can do a quick Google search too on cat fuel filters, and you can find all kinds of information out there about cat fuel filters. For the lube filters, again, our engine oil filters have spiral roving, which really differentiates us and helps with capturing and retaining those particles. So that particle count is huge. There's a big difference when you have spiral roving versus without spiral roving, and most of it is dealing with vibrations within the component or the engine. Hydraulic and transmission systems are different. If you'll notice, when you look at a transmission filter that you get from us, it'll say a transmission filter. But if you look at a transmission filter that you may buy from a different manufacturer, it'll say hydraulic filter. Caterpillar knows their transmissions, and they know that transmissions have different filtering requirements than hydraulic systems. For instance, their transmission filters have lower differential pressures, meaning that the transmission spends less time in bypass during cold startups. And if we can put more of that fluid through the filter, it does a better job. All right, well, if we don't have any questions, I would like to tell you about our next 2 shop talks. May 20th, we've got the Cat Inspect app, and then on May 27th, we've got parts.cat.com coming up. So those are both real interesting topics that we'd like to hear more about and see more about. That Cat Inspect app is a free app that the Caterpillar built, and it helps us with doing either daily inspections on machines or PM inspections, all kinds of cool stuff. So tune in and check out that May 20th Cat Inspect app. I would like to finish off with giving you our email address. So here you can go to or email us at shoptalkchannel@cartermachinery.com if you want to learn more about filters, or if you have any questions that we'd like you just to drop us a line and tell us what you think. But very much appreciate your time. Carter Machinery appreciates your business, and we hope that you have a good, safe day.